right, let's take a look at what happens to our scale factor when we're looking at area and volume. Okay, so the activity that you did in the yesterday's class was hopefully getting you to see that when we square or when we double the length or the width, or we reduce the length or the width of an object, its area doesn't just get doubled, right? So if we have a square that's 1 by 1, right? A square with a 1 by 1 dimensions, its area equals 1. Right? 1 times 1 is 1. If I take that same square and I double its dimensions, right? So what was 1 becomes 2, and what the length was 1 becomes 2 here. What's our area? Our area is 4, right? And clearly we don't double 1 to get 4, right? So what happens is we have to also change our scale factor. Our scale factor gets changed as a result of that when we're talking about area. Okay, sorry, that's not the best wording. Sorry. Hopefully these notes will make a little bit more sense. A scale factor, then the area of the similar 2D shapes are our scale factor squared, right? If we double our dimensions from 1 to 2, our k equals 2, right? But notice that when we square k, 2 squared is 4, then we can see what our new area is. Okay, k is still 2, but k squared describes how our area has changed from one shape to the next. And you can see that we have this formula, this really spread out formula over here to kind of explain that. So k squared is equal to our area of our similar 2D shape over the area of the original shape. Again, I'm not a huge fan of that wording, so I kind of like to make my own formula where I look at k squared is the new area over the original area, right? So k is new over original, but k squared is the new area, right? That new two-dimensional measurement over the original two-dimensional measurement. All right, what does this look like in a problem? Well, in our first example, which photocopied very darkly for me, sorry, I think you can see that these are pictures of the Golden Gate Bridge in your notes. We've got a photograph and its enlargement, and we're being told that they're similar in shape. Okay, so they're in proportion. The smaller photograph has an area of 56 square centimeters. What is the area of the larger photograph? Well, what we need to be able to find is, yeah, we're looking for the new area. So this is our original, and this is new, right? Because it's an enlargement. So let's use our formula. K squared equals new area over original area. Okay. Now we know that we're looking for the new area. That's what we're solving for, right? That's what we don't know. The original area, we're told, is 56. Problem is, we're not sure what the value of k is, but we are given some other information here in order to determine k. So k is going to be new over original, and we've got this dimension. We've got 18, right? This side length is in proportion with this side length, right? Because they're similar in shape. We're told that in the problem. So 18 over 12 is 1.5. That's our K value. That's our scale factor to go from the original to the new. This new guy, the dimensions are 1.5 times bigger. Okay, but because we're going to use K in an area problem, we need to square it. Okay, this can get really tricky. I know that these are the problems that students typically have kind of the hardest time working with. Just keep practicing, and hopefully they'll kind of make sense eventually. All right, so let's get this new area isolated. So our new area is 1.5 squared times 56, which is 126 square centimeters. Okay, so we needed to figure out what K was first, and then use that K in a K squared equation. Okay, that's how we solved this problem. With Jasmine here at the bottom of the page, Jasmine's making a kite from a 2 to 25 scale diagram. Okay, so let's think about what that means for a second. 2 to 25 scale diagram. So this is our diagram, and this is our actual kite. Okay, and we're going to use this to get K. So K is new over original, and I think K is the easiest to work with when it's in terms of a decimal, because we have access to our calculator for everything. They're just a lot easier to work with when they're in decimal form. So our new is 25 over 2, K is 12.5. Okay, so we found what K is, and now what we want to do is we want to figure out how much fabric she'll need for her kite if the area of her scale diagram is 20 centimeters. All right, so let's go back to our area, right? We know we're dealing with area. We're told area. We also have centimeters squared. We're also talking about fabric for a kite. Fabric comes in 2 dimensions, right? So it covers an area. So there's lots of things in this question that tell us we need to use this K squared formula. And okay, so K squared, well, K is 12.5, so we want to square it. Our new area is going to be the kite that that Jasmine is making, and the original area was 20. Right, 20 centimeters squared. We don't need to put units in this these equations. Okay, they might kind of mess us up a little bit. And so now our kite area is going to be 12.5 squared times 20, and that equals 3,125 square centimeters. Okay, so again, we had to do that same process. We needed to figure out what K was so we could use K squared in our question. Okay, so anytime you're looking for area, right, we need to consider K squared, not just K. All right. Let's take a look at Jim's laptop problem here. Jim's laptop has a monitor that has dimensions of 9 inches by 12 inches. The image on the laptop is projected onto the screen of a whiteboard. According to the documentation for the whiteboard, the area of the screen is that very precise number of 2,836.6875 square inches. And we're being told that the image on the whiteboard is similar to the image on the laptop, right? So same it's in proportion. Determine the scale factor used to project images onto the whiteboard. So in this question, we're going to find K, but we aren't going to do it the same way. We're not given dimensions that are similar, right? Not single dimensions, not lengths or anything that's, kind of similar in one dimension. We're actually given the area of the new area of the screen, and we're given the area of the original just doesn't look like the area of the original, right? So the area of the original is 9 times 12, which is 108 square inches. Okay, so we've got a new area and an original area, and we're looking for a scale factor. We're looking for K. Tricky thing here is we can use our new area and our original area to find K squared, but not K. So we'll have to do one more step in order to find K. So let's work with what we got so far. K squared equals our new area over our original area. Our new area is this very big number here over, and that's K squared. So K squared, when I put this in my calculator, gives me 26.265625. Now I'm not looking for K squared, I'm looking for K. So I'm going to square root both of these, and I'm getting a K factor of 5.125. Okay, that's my scale factor. K squared isn't a scale factor. K is a scale factor. So just make sure that if you've solved for K squared, you do that extra step of square rooting in order to get K. All right, now that we know K, we can determine the dimensions of the whiteboard, right? The length of the whiteboard is going to be 5.125 times bigger than 9 inches, which in my calculator, I get 46.125 inches. The width is going to be 12 inches times my scale factor, 61.5 inches. All right, now, if I did that right, if I take 46.125 and I multiply it by 61.5, I get this area of the whiteboard, right? So that's how that scale factor and K squared are related. Okay, so hopefully that helps, and that you kind of see how those numbers all fit together. I'm going to pause this video. I'm going to post the volume problems in a separate video because this one's getting kind of big.